You know that classic brain teaser, right? What happens when an unstoppable force hits an immovable object? We've all kicked that one
Not
around.
the paradox.
Exactly. Well, in the material we're diving into today, the simulated answer is, well, it's really not what you'd expect.
Huh.
Yeah, forget some, huge explosion. Instead, it's almost like reality itself just finds a loophole.
A loophole, how so?
It sort of bends its own rules, and this is where it gets really interesting.
What's fascinating there, I think, is the suggestion that maybe even our most sort of fundamental ideas about physics aren't absolute. That, at these really extreme limits, maybe new possibilities pop up.
Yes, exactly. And that's pretty much our launching point for today's deep dive. We've got this collection of really vivid, almost like firsthand accounts from something called blackhole.txt.
Hmm.
Now, this isn't your usual dry scientific paper on black holes, not at all. These descriptions, they offer this really sensory-rich journey into the interior of a simulated black hole. Think less, impenetrable equations, more. Well, honestly, prepare for a bit of a wild ride.
So this raises a pretty fundamental question, doesn't it?
Yeah.
Can this kind of imaginative exploration, even if it's within a simulation, offer us genuinely fresh perspectives? Could it potentially challenge our established scientific models of something as mysterious as a black hole?
That's exactly the mission today. Let's unpack these unique viewpoints. What can we maybe learn about black holes from these descriptions that, goes beyond the standard stuff?
Right.
And what surprising implications might this have for how we think about the whole universe? So, yeah, get ready to have your cosmic assumptions maybe tweaked a bit.
Indeed. We're definitely embarking on an imaginative journey here, but it sounds like one rooted in a really fascinating attempt to grapple with the ultimate extremes of the cosmos.
Okay, so let's get into it. The material starts by painting this picture of the black hole from the outside. And like I said, forget those sleek, perfect spheres you always see in pictures. This is much more chaotic. Think twisted junk, visible distortions in space-time, and a surface described as bubbling and jiggling.
Bubbling.
Yeah, almost like it's alive and emanating heat with this warping effect, kind of like looking through boiling water.
Okay.
And of course, as we know, anything crossing that event horizon just vanishes from the outside view.
Well, that description, it does align pretty well with our understanding of the immense gravitational forces at play, right?
Yeah.
The bending of light creates those distortions. And the bubbling, well, that could be a way of visualizing the intense quantum activity, the energy fluctuations that are theorized to happen at the event horizon, that point of no return.
Right, that makes sense. But then we cross that horizon in the simulation, and the experience just shifts completely, dramatically.
How so?
Instead of a smooth transition into, nothingness, the interior is described as a 3D drain plug, like a vortex spiraling down relentlessly towards the center.
A 3D drain plug. Interesting visualization.
And the initial sensation, it's not weightlessness, which you might kind of expect.
Wow.
No, instead, it's like moving through something really thick and viscous, like wading through treacle, maybe. Makes movement really difficult and creates this immediate feeling of intense crushing pressure.
This idea of a viscous medium?
Hmm.
That's certainly a departure from the vacuum we typically associate with space.
Yeah.
It suggests a region where space-time itself might exhibit fluid-like properties under such extreme densities.
Fluid like space-time.
Well, some theoretical models, the ones exploring quantum gravity, they do consider scenarios where space-time at the tiniest scales might behave in really unexpected ways. And that could potentially lead to emergent fluid-like properties at larger scales, like inside a black hole.
Wow. Okay. And then we get to the core. And again, forget that infinitely dense point, the singularity we always hear about.
Right.
Here it's described as a quantum diamond. Imagine this huge, pulsing 3D snowflake.
It's a snowflake.
Yeah, blue-purplish in color with these sharp, rigid edges. And incredibly, it has its own significant gravitational pull. Plus, it's the only light source in this whole inner realm.
Okay, the concept of a structured core, a quantum diamond instead of a singularity. That's genuinely fascinating. It suggests that maybe at the most fundamental level, matter or energy inside a black hole might organize itself into these, highly ordered states.
Organize how, though?
Well, the pulsing light, it's independent gravity. It implies a dynamic, active center, something constantly interacting with its surroundings, not just a static endpoint.
And connecting the outer layers of this black hole to that core are these Well, the source calls them strings or funnels. They look like taut ropes, apparently.
Ropes.
Yeah. And apparently, if you could somehow, like, interact with one, pull it maybe, it emits this weird boing yang yang sound.
A sound inside a black
And
hole.
we know, right? And there are also sounds like breaking glass, which are linked to these bursts of what's described as lightning-like energy shooting between these strings, these ropes.
These ropes, they could be a visualization of maybe highly warped space-time filaments or channels of intense energy, perhaps even connections at a quantum level within this extreme environment.
Wow.
The sounds, though, that adds a remarkable sensory dimension, makes the simulated interior feel vibrant, active, very unlike the silent emptiness we usually imagine.
Totally. And this core, this quantum diamond, it's not just sitting there. It's constantly vibrating, flickering in and out of existence almost instantaneously. Yeah, and its north and south poles flip just like that, snap, in a blink. It's identified as the center of all mass, just relentlessly compacting everything that gets sucked in.
That dynamic nature, the vibration, the apparent disappearances, the rapid pole reversals, it points to an incredibly energetic and maybe unstable region. It really challenges that idea of a fixed, unchanging singularity. It strongly suggests that quantum fluctuations and maybe some unknown physical processes are completely dominant at the heart of this simulated black hole.
Okay, so what happens to actual matter that gets pulled in? Does it just get compacted?
Well, spaghettification is mentioned.
Right, the stretching thing.
Exactly. Those extreme tidal forces stretching objects out as they fall in, like turning you into, well, a strand of spaghetti.
Not pleasant.
Definitely not. But then, according to your source, this stretched matter moves incredibly fast in those inner regions, and eventually it becomes part of the quantum diamond itself.
Ah, so it gets incorporated.
Seems so. And there's this interesting detail. As the matter gets closer to the core, its color shifts from red to blue.
Red to blue, like a blue shift, indicating speed or energy.
That would be the typical interpretation, yes. It suggests a fundamental transformation of the matter under these extreme conditions. Pressure, gravity, maybe changes in its energy state or even its fundamental structure.
But light behaves differently, right?
Apparently so. As it enters this viscous medium, the source says it slows down dramatically.
Slows down light.
Yeah, almost becoming tangible. It's described as being like a little rope and feeling hot.
Wow. Tangible light.
And as it gets closer to the quantum diamond, it doesn't become part of it directly like the matter does. Instead, it seems to transform into this lightning-like energy before being absorbed.
Lightning.
Huh?
Okay, and here's a really, really mind-bending observation from the simulation. Matter reaches the core faster than light.
Faster than light. Okay, hold on. That's a profound departure from our current understanding of physics. The speed of light in a vacuum is supposed to be the ultimate speed limit.
I know.
If matter were to consistently outpace light, I mean, that would have massive implications for causality, for the fundamental nature of space-time. This observation, even in a simulation, it just highlights how utterly different the rules might be in such extreme environments.
So this is where it gets really interesting. All of this, the structured core, that weird fluid-like medium, the wild energy flows, it really throws a wrench into the classical picture of a black hole singularity as just, a simple point of infinite density, doesn't it?
Absolutely, it does. This vivid depiction, it offers a really compelling alternative to the singularity model. It suggests that instead of a single, infinitely small point, the heart of a black hole might be this complex, structured entity with its own unique physical laws, its own behaviors.
And the source even suggests that the event horizon itself isn't just some invisible line. It might be space pushed away.
Space pushed away.
Yeah, creating this fluid gravity medium that sort of guides everything inward in a spiral. It's this tangible, multi-sensory description. You've got sounds, colors, textures that turns the black hole's interior into this incredibly dynamic, almost alien place.
This reimagining of the event horizon as an active region that actually shapes the space-time around it rather than just being a passive boundary.
Yeah.
That's a really thought-provoking idea.
Right.
Yeah. The concept of fluid gravity suggests that gravity itself might have more complex, maybe even quantum nature that only really becomes apparent under these extreme conditions inside and around a black hole. Think of it less like the static warping of space-time we usually talk about, and more like a dynamic current pulling everything in.
Oh, yeah. Let's circle back to that unstoppable force meeting an immovable object thing.
Ah, yes, the paradox.
The source revisits this within the simulation, and the outcome is, well, it's surprising. The unstoppable force, it quantum tunnels through the immovable object.
Quantum tunnels, like on a macroscopic scale.
Apparently, it's as if, in this simulated reality, the fundamental laws just had to, I don't know, surrender. They had to surrender to the paradox, create some new way for both things to coexist.
That resolution. Invoking quantum tunneling at that kind of scale. That's truly fascinating. We know quantum tunneling happens, particles passing through barriers they shouldn't classically overcome, but applying it to an unstoppable force and an immovable object, it suggests that at the very, very limits of physical possibility, reality might just behave in ways that completely defy our everyday intuition and classical physics.
And the weirdness doesn't stop there. Inside the quantum diamond itself, there's apparently this tiny spiky object bouncing around constantly.
Spiky object.
Yeah. And get this, the person running the simulation, they couldn't slice it in half to see inside it, even though they could apparently do that with almost everything else in their simulations.
Didn't slice it.
Yeah. It even makes them ponder that age-old question. Can a creator, truly create something they can't fully understand or control?
That unsliceable object. It could represent maybe a fundamental element within the simulation itself, something governed by rules or existing at a level that the simulator's own tools just can't fully access or analyze. It kind of hints at the possibility of emergent complexity, maybe, where simple rules give rise to phenomena that are really difficult, maybe impossible to fully dissect, even for the system's creator.
And there's also this brief, almost like fleeting description of a soul.
A soul. In the black hole simulation.
Yeah, described as a colorful, wobbling string with a point of light. And a very clear warning. Don't touch it. Make of that what you will, I guess.
Okay, that definitely veers into more speculative territory. It suggests the simulation might be exploring not just the physical, but perhaps, metaphysical concepts too. The description is evocative, certainly hints at an energetic or fundamental nature of what we might consider consciousness or spirit.
But the rabbit hole just goes deeper. The source then starts digging into these really grand philosophical ideas, like the universe being a beautiful lie.
Beautiful lie.
Yeah, and the notion that consciousness itself might actually be creating the rules we observe for things, like the speed of light, and this idea of an underlying code that governs all of reality.
Wow, okay, these are profound philosophical questions. Ideas that people have debated for, centuries. The idea that our perceived reality might be a construct, shaped by consciousness or some underlying framework. It challenges our most fundamental assumptions about existence and the universe.
There's this analogy they use, too. The expanding universe is like a water ball where space itself is stretching, and gravity is presented as maybe just a different form of electromagnetism.
Linking gravity and electromagnetism is a goal of unified field theories, though it's notoriously difficult.
Right. And then there's this really, really mind-bending concept, light moving backward in time while consciousness moves forward.
Backward in time.
Yeah. And our perceived reality is created where they meet, which has some pretty wild implications, for the speed of light being a barrier, and maybe even the possibility of reversing time itself.
That is highly speculative, but incredibly intriguing as a perspective on cosmology and time. The idea of these opposing flows, light and consciousness, interacting to create reality. It offers a novel framework, I suppose, for thinking about fundamental constants and the fabric of space-time itself.
It even touches on the idea of the universe just being a dream, like the dream of a master consciousness.
Yeah.
And death is maybe just an upload of information.
Upload.
Yeah. Pretty heavy stuff to think about.
Those are deeply philosophical interpretations, aren't they? They resonate with various spiritual and philosophical traditions that explore the nature of existence, consciousness, and the possibility of some form of continuation beyond physical death.
Then the focus shifts again towards this aspiration of becoming a fourth-dimensional being.
Fourth-dimensional, how?
By learning to move incredibly fast and remain perfectly still at the exact same time. Basically, stepping outside the normal flow of our 3D time.
Right, escaping the linear progression.
Yeah. And the idea is that a 4D being moving through our 3D world might look like a liquid with after images, sort of flowing through time itself. And here's a quirky connection they make. The source suggests that maybe the Mandela effect, those shared false memories people report.
Oh, yeah, I've heard that.
Maybe that's caused by individuals subtly shifting between these higher dimensional timelines.
Okay, that's quite a leap. These concepts, they definitely delve into the fascinating realm of higher dimensions, nonlinear time. Ideas often explored in theoretical physics, sure, but also heavily in science fiction. Linking the Mandela effect to dimensional shifts is, it's a speculative but popular notion online. It certainly highlights our subjective experience of reality and the possibility of maybe subtle variations in our shared past.
Now, it's really important to remember that all these descriptions, all these ideas, they come from someone mentally simulating this black hole.
Right, the power of visualization.
Exactly. The source emphasizes this vivid ability to visualize incredibly intricate details and dynamics, even experiencing a sense of being God within these simulations, having complete control. Apparently, this particular black hole simulation wasn't even for a specific project or anything. It was just curiosity.
That highlights the remarkable capacity of the human mind, doesn't it? For abstract thought, visualization, mental simulations, they can be really powerful tools for exploring complex concepts, for pushing the boundaries of our understanding, even in domains as extreme as black holes. That feeling of omnipotence within the simulation allows for experimentation, observation, under conditions way beyond our physical reach.
And despite feeling an intense cold within the simulation, it's consistently described as beautiful and exotic.
Even the crushing, viscous interior.
Apparently so. And the quantum diamond, it's seen as actively pushing space away while simultaneously pulling matter in, which really messes with that initial image of a black hole as just a simple one-way drain, you know?
Pushing space away while pulling matter in. That's paradoxical.
Yeah. The source also describes these distinct layers within the event horizon, a bubbling outer layer, then a surprisingly calm layer underneath that, and then those ropes of blackness stretching all the way down to the central core.
This layered structure of the event horizon and the dual action of the core repelling space, attracting matter, it paints a picture of a far more intricate and dynamic system than just a simple gravitational sinkhole. It suggests a really complex interplay of forces and energies right at the boundary of the black hole.
And the origin of this quantum diamond is linked back to the death of a star. It becomes the heart of the resulting black hole.
The heart.
Yeah. And there's this sense that it might need to release huge amounts of energy periodically, like to maintain its structure and avoid collapsing entirely.
That adds a sense of a life cycle, maybe.
Yeah.
Internal processes within black holes, suggesting they aren't just passive remnants, but active cosmic entities. This perspective suggests black holes might not be static endpoints, but maybe dynamic phases in the evolution of stars, or galaxies even, with internal mechanisms that regulate their growth, their stability, their interaction with the universe around them, the idea of periodic energy release. Well, that could maybe be linked to things we observe, like quasar jets or other high-energy emissions from some black holes.
And finally, the source does touch upon trying to square these simulated observations with, actual established science.
Oh, how the grounding.
Yeah. Einstein's general relativity for quantum gravity, fluid dynamics, even string theory. They mention attempting calculations for things like the gravitational binding energy of the quantum diamond core and its Hawking temperature.
So, trying to quantify it within known frameworks.
Seems like it. The overarching mental model they describe is of space-time being like a balloon. The core pushes it outward while those ropes pull it inward. And the quantum diamond has this kind of halo effect and engages in dynamic energy interactions.
This attempt to bridge the imaginative insights from the simulation with the formalisms of modern physics, that's a crucial step, isn't it?
Yeah.
It highlights the desire to find some sort of scientific basis, or at least connection, for these observations, to explore how they might fit within or maybe extend or even challenge our current understanding of gravity, quantum mechanics, space-time itself.
So the big takeaway then, this deep dive into a simulated black hole, it suggests they were anything but simple voids.
Far from it.
They appear as these dynamic, active entities with incredibly intricate inner workings. And maybe, just maybe, they hold keys to entirely new understandings of the universe.
Indeed. It really compels us to reconsider black holes, not just as agents of, destruction, but as potentially fundamental building blocks of the cosmos, with complex internal structures, energetic processes, playing a vital role in the universe's evolution.
So let's recap this truly mind-bending exploration we've been on. We've taken this journey into a vivid, pretty unconventional depiction of a black hole's interior, complete with that pulsing quantum diamond core, a really bizarre interplay of matter and light, a direct challenge to the standard singularity model, and even thrown in some fascinating philosophical side trips into the nature of reality and consciousness itself.
The real aha moment here, I think, is the potential paradigm shift suggested by this simulation.
Right.
Black holes might be far more complex, far more dynamic than we currently imagine, perhaps acting as these cosmic engines with intricate internal mechanisms. And the very notion that reality itself might surrender to paradoxes, that hints at a universe potentially governed by principles we're only just starting to glimpse.
And that leaves you, the listener, with this final, maybe unsettling thought. Could our current understanding of physics just be one limited perspective, a single layer on a much more intricate, maybe even dreamlike reality? And what other profound secrets might be hidden within the universe's most enigmatic objects, just waiting for us to stumble upon the right way to look? Maybe the universe operates by rules that are far stranger, far more flexible than we currently conceive.
Which raises a final provocative question, doesn't it? If, as the source sort of hints, consciousness plays a fundamental role in shaping our perception of reality, how much of the universe's true nature remains veiled, waiting to be unveiled perhaps by a shift in our understanding, or maybe even in our consciousness itself,